Hey, welcome back. I'm Corey, and we're about to get started on day 6 of Advent of Code in Rust, doing 2 puzzles today to try to get caught up. If you missed the previous days, check out the playlist up top for all my solutions, and don't forget to like and subscribe for more videos. Let's give day 6 a try. Okay, let's get started on day 6. Day 6, tuning trouble. The preparations are finally complete. You and the elves leave camp on foot and begin to make your way toward the Star Fruit Grove. As you move through the dense undergrowth, one of the elves gives you a handheld device. He says that it has many fancy features, but the most important one to set up right now is the communication system. However, because he's heard you have significant experience dealing with signal-based systems, he convinced the other elves that it would be okay to give you their one malfunctioning device. Surely you'll have no problem fixing it. As if inspired by comedic timing, the device emits a few colorful sparks. To be able to communicate with the elves, the device needs to be able to lock on to their signal. The signal is a series of seemingly random characters that the device receives one at a time. To fix the communication system, you need to add a subroutine to your device that detects a start of packet marker in the data stream. In the protocol being used by the elves, the start of packet is indicated by a sequence of 4 characters that are all different. The device will send your subroutine a data stream buffer, your puzzle input. Your subroutine needs to identify the first position where the 4 most recently received characters were all different. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first such. Specifically, it needs to report the number of characters from the beginning of the buffer to the end of the first 4 such character marker. Okay, so we need to find the marker and give the index of the last one, it sounds like. For example, suppose you receive the following data stream buffer. After the first 3 characters have been received, there haven't been enough characters received yet to find the marker. The first time a marker could occur is after the 4th character is received, making the most recent 4 characters MJ, QJ. Because J is repeated, this isn't a marker. The first time a marker appears is after the 7th character arrives. Once it does, the last 4 characters received are JPQM, which are all different. In this case, your subroutine should report the value 7 because the first start of packet marker is complete after 7 characters have been processed. Here are a few more examples. How many characters need to be processed before the first start of packet marker is detected? Okay, so we have multiple examples this time. We don't just have one, which is nice. And okay, we're gonna treat this as our actual example input, but I guess actually we just need to create a new cargo. Oh, let's go out to the root though, and we'll do a new cargo new again, 406. And what is this one called? Tuning trouble. Name tuning trouble, and we want it to be a lib again. Let's add that to our cargo workspace. Trouble. Okay. CD to 6. Cargo test. And there we go. Awesome. We can get started. Let's pull the file open. And great. Let's take our this and make an example.input. Awesome. And okay, example 1. We might have a few examples this time. Part 1. Okay, let input equals include string for example input. Let the answer equal part 1 of input, and assert that answer is 7. Let's make the function a public function called part1. It takes some input string and returns a usize because it's an index, so we'll make it a usize here. And let's just make that to do. And there we go. That'll be our boilerplate. Let's do this while we're here. Let's make this example 1. And actually, do I want the files? That's like really short. I could just do this inline. Let's just do this inline. Let's get rid of this file. This is the first time we're not going to use the file, but that's okay. Okay, so we have our input. It doesn't do this yet. It's going to fail with not yet implemented. Not yet implemented. Perfect. Okay, let's see how we want to implement this. So this feels really iteratory to me. What I'm thinking is that we can do like input.characters. That'll give us an iterate of characters, and then I want, maybe it was an iter tools, but we're gonna look through what we get from iterator alone. I wanted something about peaking, because I think if I could peak and look, so peaking usually means, yeah, peakable. This usually means that I could look, that can peak to get the next element without consuming it. So this, except I kind of want to be able to do a multiple peak, which is not what peakable's gonna do. And that's all we get. But I think I was looking at iter tools from in Rust, and I think this one might have a peak nth. Drop-in replacement, which adds a peak nth method, allowing the user to peak at a value several iterations forward without advancing the base iterator. So I think I want peak nth. So this differs from multi-peak. Oh wait, what's multi-peak? Okay, let's look at peak nth and multi-peak. Peak nth. This differs from multi-peak in that subsequent calls to peak or peak nth will always return the same value until next is called, making reset peak unnecessary. An iterator adapter that allows the user to peak at multiple next values without advancing the base iterator. Okay. Not sure I really, multi-peak, and then we can peak, 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 next, peak. Okay, got it. I think peak nth feels better without advancing it. Will always return the same value. Oh, okay, well that, no, so peak nth. Peak nth. Okay, I need to figure out how to use peak nth. But first, let's do cargo add iter tools. Not sure if I want multi-peak or peak nth. Let's peak next, or peak take while. Oh, wow, okay. Pass a reference to the next iterator element to the closure except. If except returns true, return it as the next element. Otherwise, peaking next. Wait, so how do I actually use their peak nth? It's a function. Okay, so I should just be able to call peak nth on something. Is it that I wanted to do like peak nth and then I do input dot pairs? Yeah, okay. That's fine. And then what can I do with this? It returns a peak nth, which has, okay, cool. So yeah, I can then look at the, okay. So now, I want to do for, oh, and I want to enumerate this. Enumerate. Oh wait, no, this isn't what I want. Well, maybe it is. So what I was thinking was that I could go over my iterator, but I don't think I can go over the iterator if I want to call peak on it. So maybe this isn't what I want. And I wonder if there's a better, so what I kind of want is just to get an array of all four of them next to each other. And then I can just see if they're the right thing. But I'm not sure if I have an easy way to do that. Intersperse with values interspersed, no. Intersperse with, leave, fold, equal. Iterator for, oh, so this is the enumerate, similar to into iterator enabled version of iterator enumerate. Got it. Drop in without advancing the base iterator. So if I do the iterator manually, I can use peak nth to do it. but like I'd rather not. So is there a different way to do it? I just want a thing that'll give me in groups of 4. It's kind of like cons, Rust iterator methods. Like I feel like there's a method that just is what I'm looking for here, but I'm not positive. Intersperse is partitioned, is sorted, map while, partial compare, partition. I don't think partition, no, partition breaks it into 2 halves. Peekable position, no, that's that. Product, reduce, scan, take while. And it's not that I want to put it into chunks. Let's vec. Let's look at what I can do on a vec. But chunks is also not what I'm looking to do because I want things to repeat. Okay, so here, yeah, those are all of those, but I don't want chunks. I would chunks exact, chunks mute. Oh, so chunks exact, that would have been cool. I could have used that to get the exact sized ones out. But that's not what I'm looking for. Partition dedo partition point R chunks. Oh, that's from the other side or something. Reverse. Interesting. Still not what I'm looking for. Select, sort, splits, take, windows. Windows. That feels. Oh, wait. All contiguous windows of length size. The windows overlap. If the slice is shorter than size, the iterator returns the values. Perfect. That's what I'm looking for. Characters.windows of length 4 dot enumerate actually window, yeah, enumerate, and then I want to find where I don't care what the index is and the window yeah, and I want to find the window. That's why this doesn't like it. It doesn't. There we go. Okay. And then window here, it doesn't know what this is. No method windows found for, oh, because I have to make this a vec. Let characters equal input. You're going to be a vec equals input dot characters dot collect. And then this can become that. Yep, okay. Windows, where window is an array of characters, so let hash set equals a hash. Let's have it be a hash set of something equals window dot iter dot collect. We want to find the one where the hash set dot length equals window dot length. Because if the hash set is the same length as the window, that means they're all different. If we found the thing, we want to get the index out of it and add 4. Did that not work? Right. Oh, that's an option. So we want to unwrap it because we know we're going to find the thing. And that should be part 1. There we go. I'm pretty confident in it, so I think we're just gonna go with my input. My input. Let's go grab that. Get your puzzle input. Ooh, nice. A big long one. I might put this one in a file. New file. My input. Drop it in. Include the string, my input. Oops. There we go. Answer's not going to be 7, but that's okay. This will tell us what it is. 1531. 1531. I'm just assuming that's the right answer. Let's check. 1531. There we go. Let's make a commit before we move on to part 2. Day 6, part 1. Commit anyway. So really this whole thing was just getting windows. Once we found the windows method, which wasn't even in itertools, it's just on vec. So we didn't even need a crate for that, which was nifty. Oh, we didn't need a crate for that. Let's clean this up really quick while I'm thinking about it. We haven't done a ton of cleaning up solutions, but here we just, oops, did not want to do a live share. We just didn't need that at all. So good to clean up our dependencies, clean up our depths. Oops, need to actually do git. Don't even remember my own aliases, I guess. Okay, now we're committed. Let's go back and look at part 2. Part 2, your device's communication system is correctly detecting packets, but still isn't working. It looks like it needs to look for messages. A start of message marker is just like a start of packet marker, except it consists of 14 distinct characters rather than 4. Here are the first positions of start of message marker for all of the above examples. Okay, how many characters need to be processed before the start of message marker is detected? Okay, so this is like the exact same thing with 14 instead of 4, which is pretty cool because I don't think it'll be very different. And I think what we're going to do is we're going to make it generic on the number. So that'll be fun. So we're going to make a generic function. So we're going to make this function generic on a const. And what do we want to call this? Let's just call it window size. And this is going to be a u size. So what we're saying now is this function is going to have a constant size. Like this is going to be known when we run the function, but we can make multiple different versions without knowing the window size. And so we can just plug window size in here, and this is really just gonna be like the answer, like, you know, what are we doing here? So we want like start of packet index, or it's actually the uh like it's the end of it though, really, because like we're adding this to it, so it's not the start, it's like the end of packet indicator. And then these ones are gonna be the, so we're gonna use end of packet indicator, and we're gonna be generic, or we're gonna tell it which version of this function we want to use, and that's the one with 4, with the constant 4. And that should pass our part 1 here. Still, yep. Awesome. And the really cool part is now we can just take our example 1 part 2, and we just can plug this into 14 with the exact same thing, and we should just get 19 back like it says. Oh no, we didn't. Okay, so we can debug that. That's fun. I really thought that was just gonna plug it in. Oh, I think I know the answer. It's because we still have this +4 here. We need to replace this +4 with the window size. Now it's gonna pass. Awesome. Okay, so let's see what the answer for part 2 is gonna be with our input. Part 2 is with 14. We're not going to get the same number, but that's perfectly fine. And my input part 2. And 2518. 2518. And there we go. Day 6, part 1 and 2. Let's fix this test, and we will commit the code. And that will be about all. Day 6, part 2. This time we made the same function before, generic over the length, and part 2 was solved. I really liked this one. This one was fun. Mostly just because part 2 was basically the exact same thing we had for part 1 with this implementation, so it worked out really well. Okay, so that was day 6 of Advent of Code in Rust. I hope you enjoyed it. Give me a like and a subscribe if you want to see more videos, and we will be back with day 7 tomorrow. Thanks. Bye.